I want to welcome you to part 2, and this is solving inequalities. This is for lecture 3. My name is Jorge, and this is for college algebra. So we have two objectives for this particular lesson. We're going to go ahead and use interval notation, and then we're going to talk about the properties of inequalities. And then obviously we're going to solve inequalities, and then inequalities, we're also going to do combined inequalities. So the first thing I want to talk about is intervals. So let A and B represent two real numbers, and A is less than B. So a closed interval denoted by the brackets AB consists of all the numbers x, all the real numbers x for which A is less than or equal to x, less than or equal to B. Now the open interval denoted by AB consists of all the real numbers x for which A is less than x and x is less than B. So brackets less than or equal to, parentheses less than. Now a half open and half closed intervals. So the first one is parentheses AB, consisting of all the real numbers for which A is less than x or x is less than or equal to B. Now if we have bracket A and then B parentheses, this consists of all the real numbers x for which A is less than or equal to x and x is less than B. And so here is a rundown of the different possibilities that you can see. So the first one consists of all real numbers, that x is greater than or equal to x. Second one, x is greater than A. The third one, x is less than or equal to A, x is less than A, and then all the numbers, all the real numbers x. So how do we put that on a graph? So the open interval AB in the graph would be parentheses on A, parentheses on B. The closed interval AB would be brackets on A, brackets on B. The half open interval brackets A and then B parentheses. And as you can see that essentially whatever you have in the interval notation is what you're going to have when you construct the graph. And you can, I'll allow you just to run down these and just make sure you become familiar with them. So here we have an example. So we're going to write each inequality using interval notation. So -2 is less than or equal to x, less than or equal to 4. And the way that we write that is using brackets. The next one is -2 is less than x, less than 7. And we write that using parentheses. The next one is x is greater than or equal to 6. So since it's greater than or equal to 6, we use bracket 6 and then infinity with parentheses. And then the next one is x is less than -3. So then we go ahead and use parentheses for both of those. The next thing is we're going to write each interval as an inequality that involves x. So here we have the half open interval, if you will. So this becomes -1 is less than x, less than or equal to 2. The next one is -2 is less than or equal to x, less than or equal to 0. The next one is x is greater than 5, and then x is less than 1. So you can see you can substitute different values and play around with different values to see how you're supposed to write it as an inequality that involves x. The next thing is we're going to talk about a property, and this is a non-negative property. So a squared is greater than or equal to 0, and so that's a property for any real number a. So the additional property of inequality. So for any real numbers a, b, and c, if a is less than b, then if I add c to both sides, then a plus c is still less than b plus c. Now if a is greater than b, then and I add c to both sides, then a plus c is greater than b plus c. And here we have some examples here using some graphs. So let's look at some examples. So addition property of inequalities. Let's say that x is less than -5, then x plus 5 is less than -5 plus 5, or that x plus 5 is less than 0. So if I add 5 to both sides, I get an equivalent inequality. So b, excuse me, if x is greater than 2, and I add -2 to both sides, then I get x minus 2 is greater than 0. So here we have an example. So we're going to express the inequality, express as an inequality the result of multiplying each side of the inequality 3 is less than 5 by 2. So multiply both sides by 2. So we know that 3 is less than 5. We multiply both sides by 2, we get that 6 is less than 10. Still a true statement, right? So here we're going to express the inequality as a result of multiplying both sides of the inequality 3 is less than 5 by -2. So what happens at this point in time? So here we can see that if we multiply both sides of the inequality by -2, we get that -6 on one side and negative 10 on the other side. Well, we know that negative 6 is greater than negative 10, so that leads to this, that to keep the inequality true, the inequality symbol must be reversed. So if we multiply by a negative value, we have to reverse the symbol. So here's the multiplication property for inequalities for any numbers a, b, and c. I'll let you go through them, and I'm going to go ahead and show you some examples. So the first one is, let's say 2x is less than 6. Then 1/2 times 2x is less than 1/2 times 6, or x is less than 3. So we multiply both of them by the same real value. In this case, is 1/2. So b, we have x divided by negative 3 is greater than 12. So if we multiply both sides by negative 3, we end up with x is less than or equal to negative 36. So we reversed the inequality symbol. For c, here we have, so we divide both sides by negative 4. And again, we reverse the inequality symbol, so we end up with x is less than 2. And then for d, we have negative x is less than 8. If we multiply both sides by negative 1, we end up with x is greater than negative 8. Here's the reciprocal property for inequalities. I won't go through each one. You have the slides available to you so you can read them. And then we have some procedures that leave the inequality symbol unchanged. So we have 1, 2, and 3. Again, I'll allow you to look at the slides and just make a notation of these procedures. And the next thing is the procedures that reverse the direction of the inequality symbol. Again, if we multiply by a negative value or divide by a negative value, we have to switch the direction of the inequality symbol. So here we have an example. We have 5 minus 3x is greater than or equal to negative 1. We're going to go ahead and solve this. I'm going to graph the solution set. So the first thing that we're going to do is we're going to subtract negative 5 from both sides. And by doing that, we end up with negative 3x is greater than or equal to negative 6. So the next step is to divide both sides by negative 3. And then by doing that, remember that we reverse the inequality symbol since we divided by a negative value, and we end up with x is less than or equal to 2. So then our solution set would be these two possibilities. And the way that we graph that would be using this graph right here. And I want you to notice that x is less than or equal to 2. So we know this is going to be a bracket. The bracket here goes on the 2, and then the arrow goes the direction of the inequality symbol. So this is important. When you do these, make sure that you put the variable on the left-hand side, and the direction of the arrow will be whatever direction the inequality symbol is facing. So here we have another example. 4x plus 3 is less than 2x minus 1. We're going to solve this and graph the solution set. So we subtract 3 from both sides. We end up with 4x is less than 2x minus 4. So now what we're going to do is going to subtract 2x from both sides so we can get the x on one side and the constants on the other side. So we end up with 2x is less than negative 4. So now we're going to go ahead and divide by 2. And we get x is less than negative 2. So here are the two possibilities if you write the solution set. And then we're going to go ahead and graph it. So you can see again that it goes with parentheses because it's less than, and it faces the same direction as the inequality symbol. So the next thing is we have a combined inequality. So we have negative 1 is less than 3x plus 2 less than 5. So we're going to solve this and graph it. So in reality, what we have is we have two different inequalities. We have negative 1 is less than 3x plus 2, and then we have 3x plus 2 is less than 5. So we're going to go ahead and solve the first one by subtracting 2 from both sides. So we end up with negative 3 is less than 3x. Divide by 3, and then we end up with negative 1 is less than x. Now we have the second side. Again, we subtract 2 from both sides, and then we're going to divide both sides by 3, and then we end up with x is less than 1. So our solution set then would be all x such that negative 1 is less than x negative less than 1, or negative 1 to 1. And we know we're going to have parentheses on both sides of negative 1 and 1, and that's how we write the solution set. So here we have another example. So here we have 1 is less than or equal to 5 minus 2x divided by 3, less than or equal to 3. We're going to solve this and then graph the solution set. So the first thing that we're going to do is we're going to multiply everything by 3. So we're going to multiply all three parts by 3. Now, in the previous example, I separated them. In this example, I'm going to solve them all at the same time. So here what we did is we multiplied everything by 3. So now we end up with 3 is less than or equal to 5 minus 2x less than or equal to 9. So this we know how to solve. So now what we're going to do is we're going to subtract 5 from the left side, the middle, and the right side. And when we do that, we end up with negative 2 is less than or equal to negative 2x minus, or less than or equal to 4. So now what we're going to do is divide all three sides, the left, the middle, and the right, by negative 2. And then the inequality symbols change. And then we end up with 1 is greater than or equal to x, greater than or equal to negative 2. So our solution set then becomes negative 2 is less than or equal to x, less than or equal to 1. We write it in interval notation, and then we go ahead and graph it. So as you can see, the interval notation using the brackets or the parentheses allow you to know exactly how you're going to graph it. So here we have another example. So we have, so we're going to solve the inequality 3x plus 1 raised to the negative 1 is greater than 0, and then we're going to go ahead and graph it. So just remember that 3x plus 6 raised to the negative 1 is equal to 1 over 3x plus 6 greater than 0. So by the reciprocal property, we get that 3x plus 6 is greater than 0. So we're going to go ahead and solve that. So we subtract 6 from both sides, divide both sides by 3, and then our solution set is that x is greater than negative 2, so it's negative 2 infinity. So that would be an easy thing to go ahead and graph it. And then we're going to talk about creating equivalent inequalities. So if negative 3 is less than x less than 2, then we're going to find a and b such that a is less than 3x plus 2 is less than b. So here we have that negative 3 is less than x less than 2. So what we're going to do is we're going to go ahead and multiply everything by, we're going to multiply the left side by negative 3 and the right side by 2. And that gives us negative 9 is less than 3x less than 6. And then we're going to go ahead and add 2 to both sides. And what happens is that now by doing this, we end up with what we have on the top. So a is less than 3x plus 2 less than b. So here, as you can see, we're going to end up with that, right? So we're going to find a, and we're going to find b, and then we get that negative 7 is less than 3x plus 2 is less than 8. So a is equal to negative 7, and b is equal to 8. So what we did is just work backwards. So we have the solution, we work backwards to find the inequality. So here we have a real life example. So Ohm's law states that E equals IR. E is the voltage, I is the current, and R is the resistance. So an air conditioning unit is rated at a resistance of 10 ohms. If the voltage varies from 110 to 120 volts inclusive, what corresponding range of current will the air conditioner draw? So here we have that 110 is less than or equal to E less than or equal to 120. Now E is equal to IR, and we know what R is. So R is equal to 10. So we're just solving for I. So what we're going to do now is divide everything by 10. So we divide the left, the middle, and the right by 10. So we get that 11 is less than or equal to I, less than or equal to 12. So the air conditioner will draw between 11 and 12 amps of current inclusive. And that's the end of part 2 for lecture 3. Thank you.